All right, IB AI SL2. Today we're going to talk about indefinite integrals. So if you're curious about what indefinite means, the opposite would be a definite integral. So a definite integral is when you go from a to b of f of x dx. So the thing that makes it definite is that you have a start and a stop point. Today, indefinite integrals are not going to have a start and a stop point, and I'll show you guys how to do those. First up, before we get into that, this is similar to the warm-up we did last class, but if you have a derivative, 2x plus 5, how do we get back to the original function? Well, you know that the power is 1 on 2x, on the x power is 1, so that means that it used to be a square before it got dropped down 1. And with the power rule derivatives, that square had to come out in front. So a possible beginning equation for this could be x squared plus 5x. Remember, if you have a number just floating on its own, that used to be a number x, and then you just chop off the x to take the derivative. Now, this has already come up in class, but I think somebody mentioned, well, what if you had x squared plus 5x plus 10? Like, would that work? Yes, if you take the derivative of this, it will still be 2x plus 5. So it could also be like x squared plus 5x minus 7. That would have the same derivative. So you get into this game of like, well, can't I put anything on the end? Like, couldn't this be, plus a tenth or something like that? Yeah, it really can be anything as long as it's just a number and doesn't have an x involved. So where we're headed today is that if you're going to work backwards to find the original equation, you're going to put a letter on the end called c. Now, this c is called the constant of integration. C is an element of real numbers. That just means it can be any decimal, fraction, negative, positive, could be 0 even, like it can be anything. But we don't know what it is working backwards to get the original function, so we just put it like as a placeholder. It's like, hey, there's just a plus c on the end. Let's not forget about that. Here's the formal definition of everything I just said. If the derivative of capital F is lowercase f, then if you integrate lowercase f, you get capital F back, but you have to put a plus c on the end, where c is an element of real numbers. The f of x dx part is called the indefinite integral. Notice that there are no numbers on the top and the bottom. It's just an indefinite integral. The indefinite integral f of x dx is read as the integral of f with respect to x. And then that c that you put on the end, this guy right here, is called the constant of integration. First example, find the family of antiderivatives for f of x equals 5. There's so many different ways to tell you guys to integrate or take a derivative. You can be like differentiate or, find the antiderivative or blah, blah, blah. There's so many different ways to do it. So what they're asking you is to find the antiderivative. But the family part of it means that you're going to have to put a plus c on the end because it's not just one answer. It's going to be the antiderivative plus whatever number you want. So that they're using weird language, but that's what they mean, that there's going to be a plus c on the end. So if the derivative was just a number, that means the antiderivative is f of x, but then we have to put that plus c on the end. This is the family of antiderivatives. They all look like 5x plus something, but the something could be anything. It could be 5x plus 10, 5x minus 100, any real number. Next up, integrate 4x dx. Notice that there are no definite integrals on the top and the bottom. So to integrate this, you just take the antiderivative. So you have to think, okay, the power is 1 on the x, so it started out as a square, but then so we know it's like capital F of x is like something x squared, but then the 2 has to come out in front and multiply to get a 4. So that has to be a 2 in front. And then we're not quite done because you always have to put that plus c on the end. And that's it. Now, perhaps you're getting tired of this game of like, what power did it start as, and then it multiplies with the front thing, blah, blah, blah. It can get complicated, especially when there's like weird fractions involved. So here is your handy dandy rule for integrating ax to the n. First of all, you raise the power to an n plus 1, but then you divide by an n plus 1 as well. Or another way to think of that is that you multiply any current denominator by n plus 1. A and n are constants. A cannot equal 0, obviously, because then the whole thing can be 0. And n can't be -1, because then, yeah, when you try to go backwards, you get a power of 0. So a couple little caveats there. Let me show you how that rule works. So classic one where you're like, oh, if you try to think through it, like, this had to start out as a 6, but then 6 times what gives you a quarter? It can get a little complicated. So the way you do that is you just say, should we use capital F of X? What are they doing in the book? They're not. They're just going straight for it. Okay. You're going to raise the x to 1 power. That's a 5. And then you're going to divide by the 4 that was already there, but then that's going to have to be times 5 plus 1. That's this part of the equation right here. N plus 1 has to be multiplied on the bottom. So this, oh, jolly, almost got caught, plus c on the end. So then we get x to the 6th over 4 times 6 plus c. And then we get x to the 6th over 24 plus c. And then we're done. Next up, we're going to integrate all 3 of these chunks here. So this is going to be using that power rule, backwards power rule. You get x to the 2 plus 1 all over 2 times 2 plus 1. And then plus, well, we can do the same thing here. This will be 3x to the 1 plus 1 all over 1 plus 1. And then minus 1x plus c. So this is x to the 3rd, all over 2 plus 1 is 3 times 2 is 6. Then we get plus 3x squared over 2. Then minus x, then plus c. That's it. So you're always using the power plus 1 in the denominator. So power plus 1, power plus 1. Now for this one, you have to do a rewrite before you can integrate. So before we use any rule, I want you guys to rewrite that as 4x to the -2 dx. Then, using your power rule, it'll be 4x to the -2 plus 1 all over -2 plus 1, and then, of course, plus c on the end. Now, 4 to the -2 plus 1 is 4x to the -1, and then -2 plus 1 is a -1. So this becomes -4x to the -1 plus c. But then there's a rule that you really shouldn't leave negative exponents in your final answer. So you have to kick that guy back downstairs. So this becomes -4 over x plus c. And you know what, guys? That is it for the day. The rest is just practice. You got 2 homework sections. Please come ask me questions.